this is another example where we can apply Coulomb's law. So there's a point O which is over here, and at equal distances from point O we can find 1, 2, 3, 4, 5, 6, 7 charges. They are equal in magnitude as well as in sign, and they are the same distance r from the origin or the center shown here. Now these angles are all 45 degrees, so keep that in mind. This is 45 degrees and that's 45 degrees. All these are 45-degree angles. Okay. So the question is, if we place a plus Q charge at the center O, so we place a plus Q charge at the center, what is the net force acting on that plus Q charge due to these 7 charges? So let me label these outer charges as 1, 2, 3, 4, 5, 6 and 7. And then let me consider as an example the charges 1 and 5. So they are like this. So this is the line joining the two charges. We have a plus Q charge over here and a plus Q charge over here, and then this is that center point, which is like r distance from the left and the r distance from the right, and we place a plus Q charge here. Now for these two charges 1 and 5, what is the net force that is exerted at this point on the plus Q charge? So you can see this charge 5, will be exerting a repulsive force like this. So let me call that F5. And then the charge labeled 1 is also going to exert a repulsive force on the plus Q charge. And let me call it F1. You can see F1 and F2 are equal in magnitude, right? So if you consider F1, so this is the magnitude of F1, this is the magnitude of F5. We can write that as K, magnitude of Q, the smaller charge, and the magnitude of the larger charge divided by the separation between the two charges, which is R squared. So you have equal magnitude forces acting in opposite directions. So as a result, we can conclude this F1 force and F5 force will cancel one another, cancel out. Okay, so that's what we can conclude. Similarly, if you consider the pair 2, 6, the forces acting on the plus Q charge due to the two charges will again cancel out. You'll see that F2 will be equal to F6. Magnitude wise they will be equal, but the forces will be directed in the opposite sense. So they will also cancel out. So F2 and F6 will cancel out. Similarly, now we can think about 3 and 7. So then again the forces are repulsive that are acting on the plus Q charge at the center. F3 force magnitude is equal to the magnitude of the F7 force. And they are in the opposite direction, they are opposite vectors. So again, they will cancel out. So F3 force and F7 force will cancel out. So you can see 3 pairs, the forces due to 3 pairs of charges will cancel one another. So the only remaining charge is this charge that I have labeled as 4. that's a positive charge, and at the center we are placing a positive charge. So as a result, this fourth charge is going to exert a repulsive force. So if we draw that force, this is the, I'm going to draw like the axes. So this would be the positive x-axis, and this is the negative y-axis. You can see this is the plus q charge. So the net force would be in this direction. The net force is in this direction, F net, and it will make an angle of 45 degrees downward with the positive x-axis, or like, you know, if you are measuring it in the counterclockwise direction, you can see this angle would be 315 degrees from the positive axis measured in a counterclockwise direction. And what is the magnitude of this force? So the magnitude, F net, the magnitude of the force would be simply K times magnitude of Q, magnitude of big Q, divided by R squared, or we can simply write it as K lowercase q times uppercase Q R squared. So that gives you the magnitude of that force. Its direction, as you can see, it's 315 degrees. So direction of F net is 315 degrees from the positive x-axis measured in a counterclockwise direction. So that's how we write the direction for this net force, and then this gives you the magnitude of that force. Now, how do I know it's 315? Because you can see the repulsive force is along the line connecting this fourth charge and the charge at the center. So that goes in this direction, which makes 45 degree angle below the positive x-axis. So that's why, I mean, if I'm measuring in a counterclockwise direction, that's equal to 350 degrees. If I'm measuring it in a clockwise direction, then that's equal to 45 degrees. So this is how you do this problem. So even though this problem looks complicated because of the larger number of charges, but due to symmetry, some of the forces from these charges cancels out. As I showed you, F1, F5 cancels out, F2 and F6 cancels out. Similarly, F3 and F7 cancels out. The only force is from the charge that is unpaired. For example, on this side, if you found an identical charge with the same magnitude and the same sign, then you'll see there won't be a net force acting on the charge at the center, because that force will cancel out with this force. But here there's a void. As a result, there's going to be a net force acting in that direction. So that's how you do this problem.